This is a Stata tutorial on how to do a two-factor between subjects ANOVA. Besides that, we're going to show you how to do a few of the preliminary things too, so much like the homogeneity variances test and some of the descriptive statistics for a two-way table, and as well as the plots and the post-hoc method. So first thing, let's just take a look at the setup first, so we have an example problem to work with. I'm going to use computer example 1 for the two-factor between subjects design. That's you can find that one on Blackboard in the examples folder. Now you can read through this to get all the details if you want, but basically what we have is we have two factors. Factor 1, or factor A, is teaching method with 3 levels. There's an auditory method, a visual method, and a kinesthetic method. And factor B is simply gender with just male and female. And that means, of course, you have the 3 different research questions. One for the main effect of A, main effect of B, and then the interaction. And then we have a dependent variable that we're using here that will be essentially it's just a score for some achievement test. We didn't really go into a lot of great detail, and this is just a contrived little example anyway. But just assume that they're given an achievement test at the end to see if there is an impact on the teaching method and if there are differences between males and females. And you can take a look here. That's the name of the data file. That's again available, a Stata data file, and you can find that on Blackboard. And then here are the names of the variables in that data file: method, gender, and score. And here's how the levels are coded: 1 for auditory, 2 for visual, 3 for kinesthetic, 1 for female, 2 for male. Okay, so let's go ahead and go to Stata and open that. Now let's go. So you'd have to download the file from Blackboard, and then once you do that, then you can just open Stata and then open that data file. And now we don't need to do this, but let's check and take a look at our data just to make sure that everything's set up properly. I'll click this data editor button here, and that should open up. Okay. Now this might look new to you because there's, instead of numbers for coding the groups, there's actually text labels here, and they show up in blue. Well, when it shows up in blue like this, this is because I've activated a feature that's called the value labels. So instead of coding it as 1, 2, 3, it actually displays the text label that we've given it. If you want to know how to do that and how to turn that on and off, watch one of the other videos here on this YouTube channel, the one that's titled Stata tutorial for just general features and procedures. There's a few different things in there, but in there I cover how to create and turn on these value labels for categorical variables. Notice the score variable stays the same because it's just a numerical variable and there's no labels attached to those values, so they just show up in the regular black color. So these are still saved as 1, 2, for example, for here, female is 1, male is 2. It's just, it shows up using these value labels for the human user benefit, and it also is nice because it'll use these labels when we make graphs, and on tables as well. So it doesn't have that ambiguous 1, 2, and 3 where you always have to remember, okay, what was 2? Was it visual or auditory? At least we'll have a label. And you may also notice that the setup I have here in this window and also in this window may look a little different from the way you have your setup. And again, I'll refer you to that previous video on just on the Stata features and procedures, because there I show how you can customize your window. So I moved the variables and properties parts over here, and the command review is still over here. It's just I've got it to where it can be hidden until I put the mouse over it. Then it shows up and shows me all the commands I've run. Okay, so let's move on and actually get to working with the data. So one of the first things I like to do is to, and it's always a good idea to report this in your write-ups and in articles or anything like that. You should create a basic table of descriptive statistics for the dependent variable, broken down by groups or cells. So broken down by individual categories defined by each of the factors, and then also by the combinations of those levels as cells in a table. So we have two factors, so we're going to create what's called a two-way table. And again, this is one of those optional features, but it's always nice to do this in the beginning and take a look at your data, and it's always one of those things you really should report anytime you do a write-up. So what we're going to do is, there's actually a few different ways we can do this, but I'm just going to show you the way I prefer to do it. Go to the Statistics menu, drop down to the first one where it says Summaries, Tables, and Tests. Now, there's the first one here. It says Summary and Descriptive Statistics, and there are interesting. You should just come here and play around with this stuff and find all the things that you can do. But actually, I'm going to go down a little further to where it says Other Tables. And inside there, I'm going to go to the one where it says Flexible Table of Summary Statistics. Now when you do that, it'll pop up this little dialog box. Now again, this one is just my personal preference on how to do it. Those other table commands in there would do similar stuff. I just happen to like this one. So it's going to ask for a row variable. So in other words, one of the categorical variables, how do we want to organize our table? So I want to put method on the rows of the table. And then now since I have a second factor, I'm going to come over here and click where it says column variable, and then put gender in the columns. And there's other ones here for super row and super column. That's just if you have say 3 or 4 categorical variables, so a 3-factor ANOVA, and you're trying to organize your tables there. So you can just keep on extending this with more and more categorical variables to make more and more complex tables. So what I'm going to do now is decide what statistics I want to display within each cell of this table. So cells would be defined by a particular combination of some method and some gender. So auditory female, for example. So statistics, well, let's ask just for a count of how many observations are in each cell. Now we could ask for frequency, and you would get, there is a distinction. With this data set, it would be the same whether we use frequency or count of non-missing. I'll just go ahead and say, I'll go ahead and encourage you just to start, just use count non-missing, just kind of out of habit, because what could happen is when you're collecting your data, you may have a spot reserved for a subject, and say, okay, this person was in the visual learning group and was a male, and for whatever reason they didn't complete the training and you didn't get a test score, and so their score for the dependent variable would be blank. If we asked for just frequencies, it would still count that as a valid case, even though we didn't have a dependent variable. It would count it as there being someone existed that was in visual and who was male. Now, when we ask for non-missing, we're saying, okay, they're in this particular cell, and they also had a dependent variable value that wasn't missing. So I'm going to put the variable we're talking about here is the score variable. So what else do we want? I'd like to have the mean, and the mean of the score variable. And finally, let's make it standard deviation, also of the dependent variable score. Okay. So once we have that set up, you could click the OK button and it would run it and produce the table, but let me show you a little trick. There's a button over here on the right that says Submit. I'm just going to click that. It still runs it, still produces the table, except it leaves this window open so I don't have to go weird. It leaves that table open so I don't have to go searching through the menus again to bring up that command. So I may want to change something, and it may not be what I thought it was. So I may want to change something and rerun it. So that way at least the window's still open. But as you can see, it's run what we've wanted. Actually, you know what? We did forget something. I also wanted it to give us the marginal means, and the marginal statistics. So not just within the cells, but basically I'd also like another piece out here in this margin that would give us, say, everyone who was in the auditory, both males and females, and that mean over here, and the same for visual. And in here, we could actually do that if we go to options and ask it to add row totals and add column totals. Then there we go. So same table as before, except now we have these marginal totals. And we have a grand total here in the corner. So now again, if we clicked OK, which I'll do, you'll see, it'll produce what we just had. It just closes the window. So, okay. So that's some of the basic descriptive statistics, which you can see, for the auditory teaching method, the females that received an auditory teaching method, 6 of them. The mean was 41.667, standard deviation. The order in which they're listed is the same order as shown here in this command. So count, mean, standard deviation. Okay. So at this point, we could actually assess one of those. We're kind of jumping ahead here, but we could assess, say, normality, or see if there's going to be a problem with normality, because we can see how many people are in each cell now, which is 6, which is fairly few. And let me just make a little side note here. This is a contrived data example, and you wouldn't do an ANOVA with so few subjects. Again, you would need at least 12 per cell to be able to say that you wouldn't have any issues with normality. But really, that's quite a small sample, and having 6 in each cell really isn't enough to consider doing this particular design. So, moving on. So what would be our next step? Well, we would need to check assumptions. We just discussed normality here, so we could do that elsewhere. By the way, we don't have to generate this table to check for normality issues. And with 6, there may be normality issues, but again, this is just an unrealistically small sample. So let's just pretend like we're fine on normality and move on. Okay, well, independence, again, this is a made-up example and without much context, so it's hard to say. Let's just assume we have independence of each subject. And again, that's one of those things you really can't assess unless you're the person doing the research. Okay, so let's move on to our third assumption, which is homogeneity of variances. So we actually do have an HOV test, and it's just like the one we would run whenever we're doing the one-factor ANOVA, except there's one preliminary step we have to do. The assumption is that the variances within each cell are homogeneous. Now, the little, not a problem, but the issue here is we don't have a variable that says what cell you belong to. We have a variable that says, okay, you belong to this condition, auditory, visual, kinesthetic. We have another variable that says you belong to one group, male or female. However, we need another variable that actually says what cell you belong to. Since there's 6 cells, basically every unique combination of these two factors, so auditory female would be one, auditory male would be another, visual female would be the next, and so on. And there's actually a quick way to do this. You could come in here and put in a new variable and fill it in by hand, but with a very large data set that gets tiresome and unwieldy. So there's a way to do this very quickly. So what we have to do is this preliminary step, we'll have to go to the data menu and go to create or change data. Oops. And from there, go to Create New Variable Extended, and click on that. And another dialog box will pop up. And in the corner, it's called, the window's name is eGen, so extensions to generate. In other words, these are just commands to create new variables. So it says generate variable here. In this box, we're just going to type a name, call it whatever, but I'm just going to call it cell. You can call it anything you want, and call it Egbert. Doesn't really matter. I'm just going to call it cell. Okay. Now, here in eGen function, and scroll down until you find one that says group. And click on that. Okay. And then when you do that, there's going to be this box over here that says variables. And what we have to do is we'll put in this box, we're going to select just the factors, not dependent variable, just factor 1 and 2, method and gender. Because what this does is, this group variable, it's going to give us the unique, it's going to essentially make a variable that will tell you what cell they're in or what group they're in by a unique combination of these two factors. So that's all we need to do for that. So let's just click submit and see what happens. Okay. So you can see that command popped up. And that's what needs to be done. And nothing else happens on the output. So I'm going to go and close this window because we're done here. The only thing that did happen is it created a new variable that you see appear on your list of variables in your data set. And this new variable's name is cell. And it has a label over here that tells you how you made it, but it's not really needed. But let's take a look at the data file and see our new variable, cell. So if you notice, it called cell 1 any one that had a combination of auditory and female. Cell 2 was any combination of auditory and male. Cell 3 was visual female, and so on. So we had 6 different cells. So that's what we needed. So now we just run the robust tests of variance command like we did for the one factor design, just using the cell as the group. So the way to do that is we go to statistics, summaries, tables, and tests. Oops. Classical tests of hypotheses, robust equal variance test. At the very bottom of that will drop down. All right. So what variable are we concerned with? Well, that variable, actually they should probably say grouping variable here to make it, I'm sorry, they should call it dependent variable here, or response variable, just to make it more apparent what they're talking about. But we'll put the dependent variable in that first box. It says variable. Here it says variable defining comparison groups. Okay, that's a little more intuitive. That's the one we want to put cell. And we'll click submit. Looks like everything's done, so I just don't need this anymore. So that is the test for homogeneity of variance, or for the assumption of homogeneity of variances, like we did last time, except this time it's based on the 6 cells, which that is the assumption in two-factor ANOVA, is that there's homogeneity of variances from cell to cell. And again, same as last time, WO is Levine test, W50 is the Brown-Forsyth, and their p-values are over here on the far right of these 2 lines. So it looks like I'm just going to refer to the W50 Brown-Forsyth test. Its p-value is 0.424, which is very large, which is not significant, which confirms, not confirms, but it gives us evidence that we have met the homogeneity of variances assumption. So we can move on with the rest of our analysis. And by the way, if you chose not to do the initial descriptive statistics, you get them right here. So in fact, really doing that first step is kind of redundant, but still a useful tool, because mainly the way it organizes it here. But those same statistics are given again here. It just doesn't have the nice labels here. It just has the cells 1 through 6 rather than being able to divide it up into visual, male, and so on. again, if you haven't done that, at this point you could take a look at the score frequencies to see if there's any issues, to see if that would mean we're going to have to worry about normality or not. Okay, so let's just say we've met all our assumptions, and let's move on to the omnibus f-test. So the actual ANOVA itself. Okay, so what we'll have to do is we're going to go to the statistics menu, linear models and related, ANOVA/MANOVA, analysis of variance and covariance. Click that, and dialog box pops up. Okay, so here it asks for the dependent variable, and that is the score, so the achievement test score. Now here it says model. In other words, it wants all the independent variables, all the factors that are supposed to be entered into the model. Actually, I should say it wants all the effect terms. And if you remember, there's 3 effects in this 2-factor design. There is a main effect for factor A, main effect for factor B, and an interaction effect. Now, once you get used to this, you'll be able to just type it in here, which you can do. You could select the 2 factors, method and gender, and if you want, but you'd also have to tell it you want to test the interaction, and all you do then is type in method # gender with no spaces in between no spaces around the #, so it's just all one long string of letters, method # gender. The # is Stata's code for interaction. Now, like I said, you would do that once you got used to it. Let's just not even say, let's just use the model builder feature. So next to this text box, to the right, there is a small button with an ellipsis in it, just these 3 dots. So let's click on that. And it's going to pop up a second little dialog box, and it's going to help us build our model. So one thing we have to remember is that we have 2 main effects and 1 interaction effect. So leave this the way it is, factor variable. That's the rest of it is different models, so we don't have to worry about that. Specification, main effect. Okay. The first variable, we can drop down. I'll just put method there. So main effect of method. Then click this button that says add to var list. And then method shows up right there. Good. Let's see. Let's do one for gender. Main effect of gender. Let's add that to the variable list. Good. All right. So all we need is to look for an option for interaction, 2-way or 2-factor. Good. So variable 1, let's just go and put method there. And variable 2, let's put gender there. And this stuff over here, don't worry about this. This is fine. And we'll just click add to var list, and it'll put in that method # gender in this list of, it calls it var list, VAR. It's really a list of effect terms. So main effect method, main effect gender, interaction effect. So once those 3 things are in, we'll click OK, and it'll transfer those into that box, which is what I originally typed a little bit ago, but I wanted you to see this model builder feature that you can use. And that's actually all there is to do for the omnibus ANOVA. So let's just click submit and make sure that's what we wanted. So we have a method, a gender, and an interaction effect. And that's, let's see, does it check out? Let's see. How many degrees of freedom should method have? 2, since there's 3 groups, so 3 minus 1. Gender had 2 groups, so it should have 1 degree of freedom. The method times gender degrees of freedom should be that 1 times that one. So 2 times 1 is 2, so that checks out. Total degrees of freedom, 35, and I know we had 36 total subjects, so this all looks good. All right, so I'm just going to go ahead and close this window because we've got what we need here. Let's see. Now, again, so each line will contain all the information for each effect. So the main effect of method the f-test is 49.75, p-value is very small, so we just say less than 0.001. So it's significant, and so is gender. It's also significant, but it doesn't really matter because our interaction is significant. So that's gonna be our focus for the rest of the analysis. Just because interpreting either one of those is, potentially misleading because of the nature of interaction. There are some cases when you get used to this and become a little more experienced doing these two-factor analyses, there are some rare occasions when you can explore a main effect under certain conditions, but for the most part people don't really care because the interaction is the focus anyway. So I only tell you that just as an FYI because occasionally you will see articles where people do follow up with a main effect when there is a significant interaction. But that's not the typical case. And it has to be some fairly specific circumstances which are beyond the scope of what we're doing here. So we have a significant interaction. That's what matters here. So the interaction's got to remain our focus. And so that means we should move on to the subsequent steps like generating a means plot for the interaction and then a post-hoc. Also, we want to do the effect sizes. Now, with the one-factor design, we could get our effect sizes from right here where it says r squared and adjusted r squared, because r squared would be the eta squared, and adjusted r squared would be omega squared. But that doesn't really help out here because those are valid effect sizes, except they represent the whole model. So basically they represent these three effects simultaneously and together. So we would like to know the effect size of method by itself, gender by itself, and interaction by itself. In other words, three partial effect sizes. So in order to do that, we will have to actually use a command to actually get that to be computed, because these don't represent the partial effects. These are just the total effect sizes, which, yeah, it's great and all, but we're going to focus on interaction anyway. So let's try to find out what the effect sizes are there. So to do that, first thing, you do have to run the ANOVA command first. So as long as that's been run and those results are in memory, that's all that's important. So to do this one, we have to go to the statistics menu, then all the way down here to post estimation. Click on that, a dialog window pops up. And inside here there's a bunch of options with these little plus minus scroll down bars. And so we're going to look for the one that's labeled specification, diagnostic, and goodness of fit analysis. So this one, we're going to click on that little plus sign by it so it opens up. And then we're going to go in here and look for where it says eta squared and omega squared effect sizes. And select that, and click this button that says launch. It's going to open up a new window. Now when it does that, it should already have in this little menu box here, it should have effect sizes already selected. If it doesn't, scroll down till you find where it says effect sizes and select it. So what I'm going to do now there's a box here that says report omega squared. I'm going to leave that unchecked for this go, and I'm just going to click submit. Now when I do that, it will give us, you can see it gives us the partial eta squareds for the three effect terms: method, gender, and interaction. Now I'll do it again. I'm going to click this box that says report omega squared and then hit submit again, and that will give us the omega squareds. So you have to do this essentially twice to get both the etas and the omegas, but so we're done with that. So this first one, the eta squared for method, the partial eta squared for method is 0.768. Most importantly, the partial eta squared for interaction of method and gender is 0.583. And then if we were wanting the partial omega squared, you just look in this one, and the partial omega squared for method and gender interaction would be 0.555. Not a whole lot of difference, even with such a small sample, not that different. So that's effect size. Now let's do the means plot. Again, for the means plot, all we had to do first is to make sure that we've run the ANOVA with an interaction term in it, like we've done before. So it's already up here, so we know that it's still in memory. So once we're ready for that, to do a means plot, we're going to go again to the statistics and post estimation in that same window that we just had a minute ago. Then we're going to click the plus sign button next to marginal analysis. So the first one there, so I'm going to click that. And then I'm going to look for marginal means and interaction analysis. Open that box. And then I'm going to select where it says interaction plot. Once I got that, click launch. Okay, that's going to bring up a second window. And this first box where it says covariate, that's just a general term they use for, in this case, independent variables. So in this first box it says covariate. Let's put in one of the two factors. Let's just put in method. And below that, this one should already be checked where it says interaction analysis with another covariate. So with another factor, we'll select the other, so gender. And then finally, this should also be should have already been checked where it says draw profile plots of results. But if it isn't, check that. And then inside here, this is optional, but I like to select this do not draw confidence intervals for point estimates because that just kind of clutters up the drawing, honestly. So and again, that's optional. You don't have to use that one, but I like to do it because it's a much cleaner graph. So one thing to keep in mind, the variable that you put in the first box on the top, that's the variable that's going to be shown on the horizontal axis. So the three different methods will be shown on the horizontal axis, and the variable, the fact that we put here in the second box, there will be separate lines for those levels. So there'll be a line for male and a line for female. So let's run it just to so you can see what I mean. All right. So, like I was saying, method went in this first covariate box, so that means auditory, visual, and kinesthetic are put here on the horizontal axis. Gender went in the second box, so that means male, and there's a separate line for males, which is the red line, and a separate line for females, which is the blue line. Now, if we were to do it the other way around, we could put gender here and then method there. We still get a valid plot, it just will look a little different. They're both valid plots. It's really up to you as the researcher to decide which one you like better, which one makes more sense to you, which one's more intuitive. Not really a right or wrong answer here. It's kind of just individual preferences. Generally, you just report one of these. You pick one of the two versions of the plot and use that one. You wouldn't report both because they are equivalent. So, but you notice you put male and female on the horizontal axis and made 3 separate lines this time for the different teaching methods. And then, of course, on the vertical axis is just the cell means. So the blue is auditory, and on the right, this one is male. So that would be the cell mean for males who received the auditory teaching method. So, all right. Something else to keep in mind: if you find it the way it is here, if you want, you can just go here and just click this button that says copy. And if you want to put that in a Word document, all you have to do is you click copy, go to your Word document, and then just paste, Control V. Okay, let me try that again. Copy. Okay, Control V. And it'll paste in your graph, and then you can drag it around. It makes these. It does a really good job, even though it looks kind of jagged and pixelated here. Whenever you print this out, it actually smooths them really nicely, and it keeps the fonts from getting too weird. So it's actually, I'm not sure what kind of graphic they're using, but it does a really nice job of it, keeping it from getting too jagged whenever you convert it to a PDF or print it. So we're done with those. Okay. So what's left? Last thing we need to do now is consider the post-hoc analysis for interaction. Now, to do that, again, there are a few different approaches to dealing with the post-hoc analysis for interactions, and it's in many different textbooks and in the literature about how to approach it. So I'm just going to sort of show you a general way to approach this. This, for me, has worked in most situations, and especially if you're trying to pin down where an interaction is. But again, there are other ways, but to me this is the most straightforward and simplest way to handle it. So what we're going to do is we're going to use the method we discussed in class about using tetrad differences, or just tetrads, tetrad comparisons, same thing. And we need to know, really before we start this, how many tetrads are there and where are they. And so I would recommend you going back through the notes on that issue or looking at the class videos on Blackboard that have that discussion, because that would take a little bit longer here. So I'm just going to assume that you understand what the tetrads are, and in this design it's a 3x2 design, so I will go ahead and assume that everyone knows how that we are determining that there are 3 different tetrads in this particular table. So what we're going to do is we're going to go to the statistics menu, go down to post estimation once again, and so this same window pops up. We're going to look for the tests, contrasts, and comparisons of parameter estimates. That one, and open that one. And then inside there we're going to just select contrasts. Not contrasts of margins, just plain contrasts. And click launch, so we get another window. Now in this window there are a few different tabs. It should open with the main tab, but if for some reason if it doesn't, then just click on the main tab. Now here, factor terms to compute contrast for. We could type in manually the contrast if we know the code they use and the special symbols, and it's fairly simple to get to once you've seen it a few times. But this time let's just use the builder feature on here and build our contrast using that, because it's an easy way to do it. If you haven't done it in a while and you've forgotten, you can go do this method and it makes it a lot easier. So again, in this text box is where we would want to specify the contrast, but let's go to the right where it has this little small button with the ellipsis in it, and click that, and it'll pop open a third window. Now, we're doing a post hoc for interactions, so main effect really isn't an issue here. We're wanting to see where the interaction is, so let's click that for under where it says term, so effect term is what they're implying. Now that will change the setup here, and it'll give you 2 boxes. So under where it says 1 and 2, it doesn't really matter what order they go in, but let's just since we put method on rows and gender on columns in those previous tables, let's just stick with that order. So we have our two factors. So what we're saying, actually, these are the factors that are combined to produce the interaction. So what kind of contrast do we want? Well, it comes with quite a few different built-in pre-made contrasts, but none of these are actually do all of the different possible pairwise combinations of each factor. They come close. There's one that will do adjacent groups, so it'll compare group 1 to 2, 2 to 3, 3 to 4, and so on, but it wouldn't do 2 to 4. So if we want to make sure that we get all our possible comparisons or all our possible tetrads, we need to specify a custom contrast, which is the option here at the very bottom of that drop-down list, and let's do the same for this for the second one. So custom in both of those. Then when you do that, these boxes on the far right where it says custom contrast will open up. Now here is where you'll need to know what we're doing for the code for these coefficients. And you can see that in the class videos, but essentially a tetrad, in one way to think of a tetrad is when you cross a pairwise comparison for the first factor with a pairwise comparison in the second factor. And that will cross to specify 4 particular cells. So for method, we know we have the three methods: auditory, visual, and kinesthetic, in that order. So in the first one, let's say we want to do auditory versus visual, and that means kinesthetic is, for that contrast, left out. So let's do 1 space -1 space 0, meaning since those levels of method are given in that order, auditory, visual, and kinesthetic, that means the first group is auditory, it's weighted 1. Visual is the second group, it's -1, in other words, it's subtracted from the first, so a difference of the two. And then 0 for the last one, kinesthetic, because we're ignoring it for the moment. And then for male and female, well, that one's pretty simple. There's just the two groups, so 1, -1. Okay, so we've got those in. That's all we need for that first tetrad. And then once we're done there, we'll click this button at the top that says Add to Contrast List. And as soon as I do that, you notice it put this down here. And like I said earlier, that the code is pretty easy because it really is similar to what we did in class, but we'll put a curly brace, our bracket around, and open it, and then put the factor that we're going to specify first, so method. That's where the 1, -1, 0 goes. And then close the curly bracket, #, open the next curly bracket, gender 1, -1, close that curly bracket. Spaces in between the numbers and the factor names, no spaces around the #. So now again, we could type the others in now that we see how it's done, but let's just stick with the builder method and just have it do it all for us this time. So okay, so we got the first tetrad, which should be the first two groups of method and versus male and female. Now let's do the next one. That would be the first versus the third, and that means the second group can get the 0. So I'll just move that into the middle. And then there's no changes to be made here because there's just the two groups. So that's all set. Add to contrast list, and it'll put that in there. And let's do the last one, which would be group 2 versus group 3 for the methods. So the first group gets the 0 in this case. So 0, 1, -1. And again, that comparison doesn't change, so we leave it alone. Hit that button one more time, and it puts it in there. So these are our 3 tetrads now in this contrast list. So once we're satisfied that everything's in there that we want, we'll click OK, and it'll put it in this box for us. And again, we could have typed it, if familiar with the formatting of the way it codes this stuff, we could have typed that in ourselves, but it's pretty much just as quick just to use that little builder function. So one other thing we need to do is now we need to go to this reporting tab, and we need to tell it that we want to, we're doing a multiple comparison, we're doing post-hocs or multiple comparisons. We have to pick a method, Bonferrone's, SHIDAC, or Schiffe's. Any of those would work. I kind of prefer SHIDAC's method, so let's select that. And let's also select effects tables. And under here, there's a option checkbox for show effect table with p-values. So let's check that. Okay, so that should be all that's needed. So we've got that, the 3 tetrads specified. We've got the multiple comparison adjustment specified. So let's click submit. And sure enough, looks like we're good. The one thing that's not the greatest on the output is it doesn't give a really descriptive description of the tetrad that you run. It gives this kind of generic 1, 1, 2, 1, 3, 1, and these are actually listed in the order they're specified up here in this command, because it repeats the command we just ran, which contains the code for those tetrads. And so this would be that first tetrad, this is the second one, that's the third. And so they're listed in that order. The 1, 1, 2, 1, 3, 1, that specifies that that's the first comparison for method crossed with the first comparison for gender. So that piece is what they're calling the first comparison for the method. So method 1 and 2, audio and visual, and then crossed with the first comparison for gender, which is male versus female. So that's what that's specifying. Then it goes to 2, 1. So the second comparison related to method, so that'd be method 1 versus method 3, so auditory versus kinesthetic. And then again, so there's only one gender contrast, so again it gets labeled 1. So that's what those are in reference to if you really want to know, but it's not really necessary to understand that, because if you understand which one is which in the order in which you specified the tetrads up here, that's the order in which they're reported. And it does this a couple ways. It gives you, this part is kind of the standard output, and it gives you an f-test for each one of those tetrad contrasts. And that's fine, that a lot of programs use an f-test here. And then there's your p-values. So not significant, significant, significant. And those were the f-test values for those 3. Now, we'd also asked for, it does that just automatically, but we'd asked for an effects table so we could actually see the values of the contrast themselves. So the actual, if we were to subtract, in this first case, if we were to subtract or take the cell with females with the auditory method minus males with the, I'm sorry, that would be females with the auditory method minus males with the auditory method, and then also females with the visual method minus males with the visual method, and then subtract those 2 differences from each other. That would be the difference. So you would have to sort of, work through it. Probably on paper would be the best way to look at which cells are being subtracted from which, but that's the ultimate, the differences of those cells in that comparison, that's what the contrast is. So the difference in those scores would be 20 for the third contrast, for example. Sometimes it doesn't matter. Sometimes you just want to know if there's a difference. Sometimes you want to know how much. Since these were test scores and you had 20 points, you may want to know that. When it's a little more concrete of a dependent variable, like time it took to read a passage or something like that, then you might want to mention that, because it's easy to relate to that when it took 40 seconds longer to do that. Now in this table, it's the exact same results as before, except for whatever reason this time they reported them as t-tests instead of f-tests. You notice the p-values are going to be exactly the same, except, well, this one up here shows it to 4 decimal places, and this one shows just to 3 decimal places, but it's just formatting issues. The exact same test. Well, the one's a t-test, one's an f-test. These are equivalent tests because if you were to square this, you would get that. So if you square the t-test, you would get its corresponding f-test. So they're equivalent in this case, so you could report either one. Most of the time I see people report the t-test. So again, we come to the same conclusions as we did up here, that the first tetrad was not significant, and the second and third tetrads were. And if you want to see how I further interpret that and do the write-up of the results, then you should go download the Word document that comes with this example on Blackboard, because, well, actually, I can't remember if it's a Word document or a PDF, but this document here, if you go download that, this in here, by the way, it tells you how to do the very same things we just did, except using just the commands on the command line. So it walks you through that using just the commands, so that should look familiar so now that should look familiar. And then I give you an example write-up of the results. And so if you want to see how I went about reporting the 3 contrasts and interpreting them, then this is, go take a look at that. And again, that's just one way of doing it. It may take a couple times to get it the way you think is the easiest to understand, but anyway, that is how to do a 2-factor between subjects ANOVA.